Okay, we are now on slide 21. Let's go through all of those 4 examples. Calculate the pH of each of the following strong acid solutions. For A, we have 0.0167 molar solution of HNO3. Now, because it tells us that they are strong acids, we know that all strong acids fully dissociate into, so if I were to write this reaction of HNO3 in water, they fully dissociate to give you NO3 minus plus H3O plus, which means that because all of my concentration of HNO3 splits up into these 2 ions, that means that the concentration of H3O plus in this solution is going to be the same as the concentration of my acid initially. Therefore, from this, because I know it's a strong acid, I can say that the concentration of H3O plus for this solution is also 0.0167 molar. And now that I know that, I can figure out the pH very easily. Remember, pH is equal to minus log of the concentration of H3O plus minus log of this calculation, this number here, 0.0167. Make sure you know how to enter it in your calculators. That gives me a pH of 1.8. Pretty strong acid. Okay, the key to this part was just to recognize that because I have strong acids, that means that the concentration of the initial concentration of my acid is going to be the same as the concentration of H3O plus, because all of that splits, all of my acid will split into these 2 ions. So the concentration of these 2 is the same. Let's look at part B. I have 0.225 grams of HClO3 in a 2-liter solution. So I have 0.225 grams of HClO3 in 2 liters of solution. Now remember, before I can do any of these the pH calculation, remember that the pH is the minus log of the concentration, molar concentration of my H3O plus. Therefore, I can't use 0.225 grams because it's not in the correct unit. Or I can't take 0.225 grams divided by 2 liters and plug it in here. I have to find the molarity. Remember, molarity is equal to moles of your solute over liters of solution. Therefore, I have to first calculate my moles of HClO3. I have the volume, so I can calculate the molarity. To do that, I need to calculate the molar mass of HClO3, and that is 84.45 grams per mole. Now that I have this, I can calculate the moles of HClO3, 0.225 grams times, I know 1 mole of HClO3 weighs 84.45 grams. The grams cancel, leaving me with moles, and the moles are 0.0027 of HClO3. However, my molarity is moles of HClO3 over liters of solution. So I divide that by the 2 liters because I'm told in 2 liters, which gives me a molarity of 0.00133 molar. Now that I have this in molarity, I can say, well, this is a strong acid, which means that all of it, just like up here, all of it is going to dissociate to give me H3O plus. Therefore, the concentration of HClO3 is equal to the concentration of H3O plus. And this is only for strong acids. That means that my H3O plus concentration is 0.0133 molar. Now I can figure out the pH by taking the minus log of the H3O plus concentration minus log of 0.00133, and that gives me 2.9, a pH of 2.9. Okay, let's look at C. And I'm afraid, well, I'm going to write a little small. Part C. I have a mixture of, so I have 15 milliliters of 1 molar HCl diluted 2.5 liters. This is, so you can see how these problems combine concepts that we learned earlier in earlier chapters with what we're learning now. This part C combines the dilution. It's a dilution problem plus a pH problem. So we know the dilution formula, so C1 times V1 equals C2 times V2. I have the initial volume and concentration, so I have 15 milliliters of a 1 molar solution, and it's diluted to 0.5 liters. To make them in the same unit, I can say 0.5 liters is equal to 500 milliliters. Okay, I need to figure out that the second concentration. So C2 is equal to C1 times V1 over V2. C1 was 1 molar times V1 was 15 milliliters. Divide that by 500 milliliters. My milliliters will cancel, leaving me with molarity, which is what I want. And that comes out to be 0.03 molar HCl, which is the same as the concentration of H3O plus. Once again, because it's a strong acid. So to find the pH, I do minus log of H3O plus concentration minus log of 0.03, which is equal to 1.5, a pH of 1.5. As you can see, these are very small numbers because we are dealing with strong acids. I will erase this and then we'll do part D. Let's look at part D, the last part of slide 21. A mixture formed by adding 50 milliliters. So part D, I have 50 milliliters of 0.02 molar HCl to 125 milliliters of 0.01 molar HI. Okay, I need to first figure out how many moles of H plus I'm getting from this mixture or from this acid, and how many moles of HI I'm getting from this acid. So the first thing we need to do is, we know that if I'm given an amount, and I'll convert that to liters, 0.05 liters multiplied by my molarity is 0.02 moles of HCl per 1 liter of solution. My liters will cancel, so if I multiply that, that gives me 0.001 moles of HCl. Now let's do the same thing for the HI. How many moles of HI do I have? I have 0.125 liters multiplied by 0.01 moles of HI per liter. My liters cancel, and if I do that math, I get 0.00125 moles of HI. Now I know that because these are strong acids, they will completely dissociate in water to produce H plus ions or H3O plus ions and Cl minus, H3O plus and I minus, which means that the same number of moles of HCl is going to give me that amount of H plus in solution. The same amount of moles of HI will give me the same number of moles of H plus. So this is also equal to 0.001 moles of H plus. And this is also equal to 0.00125 moles of H plus. Now I know how much H plus I'm getting from each of these acids. To get to the total concentration, I need to add both of those. So I add 0.001 moles of H plus that come from HCl plus 0.00125 moles of H plus that come from my HI. This gives me a total number of moles of 0.00225 moles of H plus. Now I still can't do pH because pH, remember, is equal to minus log of the concentration of H plus or H3O plus so molar concentration. This needs to be in moles per liter. I only have moles of H plus. I need to figure out what this concentration is going to be in moles per liter. Now, this is the total amount of moles of H plus. What is my total volume? It's going to be 125 milliliters plus 50 milliliters. So my volume is going to be 50 milliliters plus 125 milliliters, giving me 175 milliliter total, or a volume of 0.175 liters. Now that I have the moles and I have the volume in liters, I can figure out the molarity. So molarity of my H plus is equal to 0.0025 moles divided by, and I'll just do H plus, divided by 0.175 liters. This will give me a concentration of 0.01286 molar H plus. Now that I know the concentration in moles per liter, I can go up here and find the pH minus log of 0.01286. And if you do that, you should get a pH of 1.89. And that is how you do. This is a little more difficult type of problem. But once again, the premise of all of these problems is that these are strong acids, which means that either when we didn't have a mixture, when we just had one acid, we considered that all of that concentration of my initial concentration of my acid is the same as the H3O plus concentration. When we have a mixture like this, we first have to figure out the moles of H plus that come from each of the acids, add all those together. That gives me the moles of H plus. But then I have to find the total volume of the solution of the mixture, because that changes the concentration. Remember, it's moles per liter, and moles per liter, if I just use 50 milliliters, is different than moles per liter if I use 125 milliliters for the volume, or if I use the total of the solution. And so therefore, that changes my concentration. So I have to first figure out the total number of moles that come from each acid. Then I have to figure out the total volume of the solution. And then I can find the concentration by dividing the moles by liter, giving me the molarity, which I then can go up here and use to find the pH. Okay, this is the end of the problems in chapter or slide 21, and I will erase this and we'll continue on with the next problems.